I'm waiting for my nice LG ductless split system. In the meantime, I have a window unit, which I have hidden behind this soundboard because I did a video once and they're like, bro, you're supposed to be this HVAC expert. You got a window unit in your background. What's going on? So Tony Mormino, HVAC TV. Welcome to the show. Welcome to the listeners. Thank you so much. I've got a guest here today. We're going international today. Right, Nathan?
We are.
We're worldwide. We're worldwide known. So Nathan, Martin, how you doing today?
I'm doing fantastic. Tony, thanks for asking.
Thank you so much for coming to the show. I'm looking forward to talking about some different issues with you from the Canadian perspective because we don't have a lot of international guests on here. So hopefully this will provide some value to the listeners. I'm certainly extremely interested. So Nathan, you are with O'dell Group in, is it Waterloo, Ontario?
Correct. Yeah. O'dell HVAC Group. My office is in Waterloo, Ontario, but O'dell HVAC Group services the entire province of Ontario through 6 different office locations.
Gotcha.
So we got office locations all the way from the west to the east of Ontario, one in London, Burlington, Waterloo, Toronto, Ottawa, and also in Sudbury, Ontario.
That sounds like a lot of Canadian names. So HVAC, you're an HVAC representation firm, and you were recently acquired by Air Control Concepts, which is how we met because I work for Air Control Concepts as well. So tell me how that transition's been working for you.
Yeah, I mean, we're in the honeymoon phases of the Air Control Concepts acquisition. It was official in March. Mm-hmm. But so far it's been a great experience working with the senior leadership team there and supporting what we're doing already in Canada, and their investment into the Canadian market has been exceptional and helping us grow our presence, not just in Ontario, but the goal is to grow the presence for Air across Canada. And that's an exciting opportunity for us.
That is interesting.
Yeah.
You'll have to have me up there pre-wintry weather. I'm from Buffalo originally, so I know I know the weather. This was a million years ago. I was just a kid, but I still remember the weather. It's quite a bit different there in February.
Yeah. No, it can be for sure. We had a pretty rough winter last winter. Yeah. With a lot of snow, but right now it's 32 degrees Celsius out today, which is, I don't know what that is in Fahrenheit, but it's it's like in the 80s, right?
Yeah.
Damn hot for us in Canada.
That's so funny. I'm from Florida. I live in North Carolina now, which is like a perfect medium between Florida and New York. And when I moved here, people were like, don't worry, you get used to the heat. I'm like, bro, I'm from Florida, man. This is like child's play to me. But HVAC rep firm. So what are your what's your major type of job you do? Do you have a specific application you focus on, specific type of equipment, or?
Well, we're a unique manufacturer's rep in that we're really strong on both we call systems products and ventilation products. We have a very strong ventilation solutions, working with Cook is our main kind of fan line, Kruger, VAVs and GRDs. Mm-hmm. So everything from fans, grills, diffusers, louvers and dampers, fire smoke dampers, fire dampers, basically anything to do with ventilation and distribution of air through a building. That's a big part of our business. In fact, more than 50% of our business is in the ventilation side of our business, and we have a really strong team that brings that to market. But then we have the system side of our business, and that is the likes of LG, VRF. A lot of custom air handling solutions. We actually have our own brand of custom air handling called Envent. We worked with a third-party manufacturer a number of years ago to come up with our own brand of custom air handling solutions, and that's been really, really successful for us. Bring that to market in Ontario. It's called Envent, but outside of
Envent.
ENVENT, yes.
Okay.
Envent.
And that's your own brand of custom units.
That is O'dell HVAC Group's brand of custom.
Okay. I've not heard of that being a thing before. Tell us a little bit about that and how that came about.
Yeah,
interesting.
Well, we've always been a strong custom air handling solution manufacturer's rep, and actually air handling in general. It marries very well with the ventilation. So we also we have some standard central station air handling solutions. Valent is another great product for us that does pre-configured air solutions. But there is a big part of our market here in Ontario where it's custom solutions. So long-term care facilities, hospital healthcare, where they're looking for products where it has integrated humidification, integrated energy recovery, and moreover, the green space, like looking at decarbonization, green efforts, we saw a real opportunity with integrating an air handling solution, custom air handling solution with LG VRF and doing their air handling unit kits. So about 4 or 5 years ago, we started doing VRF-enabled air handling solutions. And today it's probably our biggest product offering in the custom air handling. So that was the genesis of it, and trying to find a vendor we could work with. There was a bunch of vendors in the marketplace that already had some representation or not just representation, but possibly direct to market, going direct to market. And so we approached them and gave them an idea of what we wanted to do. And we thought we could work in the market. Toronto's a huge market, obviously one of the biggest market in Canada. So there's space for a couple brands of the same product. And so we were able to ink a deal with a vendor, with a manufacturer, to bring our own product to market, allowing us to focus on our engineering, which we do a lot of engineering sales, working with the consultants and applying the products and putting them on plans. And if we have an Envent solution on a project, it gives us the advantage of for the manufacturer works with us exclusively on that particular project.
Because you've developed a product specific for an application in your area, which is really unique. I like that. I've not heard of that before. I'm sure it happens out there, but I haven't heard of that. I love it.
But one of the things we can do that is really cool, that we've really got a lot of favor from engineers and owners alike, and contractors, quite frankly, is that when we supply a VRF-enabled air handling unit, it's factory installed controls, package controls, and tested. So you're not sending. In previous to us doing this with Envent, we would have to send like a mechano set to site. We'd have to send an air handler with a coil, VRF with all its packages and the controls, and the contractor would be responsible for putting all that together. But now it goes to site, gets put on a roof curb, and our team, we have an HVAC service group, will go out and do the commissioning and startup of it. And it's a one-stop shop. So
let's talk about that for a minute, because there might be a lot of viewers being like, what are they talking about? Because it's kind of a unique scenario when you connect and I might be getting it wrong too, but what I'm imagining is you're connecting the VRF condensing unit to a coil inside of a custom air handling unit. And most VRF manufacturers, or at least some of them do, I know LG does, has a kit where you can do that. So instead of taking the 20-ton VRF heat recovery outdoor condensing unit and connecting it to several indoor units, you can connect it to an actual cooling coil in a custom air handler. How did I do? Get that
That's
right?
exactly correct. Yeah.
And what are you doing with those coils in the air handling unit? Is it one big constant volume air handler, or is it a VAV air handler, or what are you doing with it?
Yeah, it varies between constant volume and variable volume, and a lot of energy recovery. So what we do from a standpoint of how it gets installed is we just extend the rails of the custom air handler and mount the condensing unit on the rails of the air handling unit. So when it ships to site and you crane it, it's craned as one package.
Package unit sits on the roof.
Exactly.
Got it.
The coils, we have very specific requirements from LG that outline what the requirements of the coils are, as far as what saturated suction temperature we have to operate at, what and what kind of pressure drop we need to have in the coils. So we just work with custom DX coil vendors to support that. And then the important thing when you do VRF-enabled air handling is to understand the limitations of VRF and any sort of DX system, in that the air entering onto the DX coil can't be below 23. I gotta get this number wrong, so don't because I haven't done this myself in a long time.
Can't be real cold.
Yeah, it can't be super cold. So you always have to preheat somehow into the coil. I think it's actually 45 degrees or 42 degrees Fahrenheit that you have to make sure you stay above into the DX coil. And staying above 42 degrees Fahrenheit can be done in a manner of a bunch of different manners, either through an electric coil on a preheat, or we can do it with a gas coil, or we can do it with energy recovery. Energy recovery obviously being the best way to do it from a energy standpoint. An electric coil, if you don't have energy recovery, like if you're doing makeup air, an electric coil is usually preferred in that it's oftentimes when we're doing VRF-enabled air handling, it's an electrification or decarbonization solution, and people don't really want to put gas in front.
It's so funny. I'm smiling because 20 years ago, you would have never heard that.
Yeah.
Or even 10 years ago. And
2 years ago.
2 years ago, right? We're going to talk about that because that's another whole thing. But I'm curious, like, first of all, thank you for translating it into Fahrenheit, because I know a lot of folks like me, I know 32-ish is kind of normal, and then it gets colder. I get all that. But, the question I have is, when is Canada going to get on the imperial system and off this old metric? I mean, come on, guys. I mean, really? That's never going to happen. So my favorite ever Saturday Night Live, which everybody knows, is the one with Nate Bargatze talking about the temperature, weights of temperatures. And it's like, how will we know what 1,000 feet is, or what we know what a mile is, or nobody will ever know? Like, we won't know. We don't know. It's perfect. This is hilarious. So I started listening to this podcast on history. It's 1 hour quick hit history stories, right? Yeah. Condensed history. And they have one on the metric system on the US, like why we're not on the metric system. And this is all news to me. So apparently back in when the country was being founded, I think it was during Jefferson's time, somebody came to him and said, hey, we need to get on, because all the states were using different things. Like some states were using grains, some were using slugs, some were using pounds. So it was a mess. So they were like, we got to get our act together. Well, someone came to him and said, hey, over in France, they're doing this thing called the metric system. We need to get there's a name for it. It's an official measurement of a meter. And then you could take that. It's basically like a really precise, I don't know what it was made out of, aluminum or whatever back in the day, probably not aluminum. Anyway, so they ordered this thing from France and it came over on a ship. Well, pirates attacked the ship and stole this thing. So it derailed the whole thing. So it got all messed, and then Jefferson wasn't president anymore, so it all just fell to the wayside. So you could blame it on pirates. It's not that we're ignorant or we're dumb. We got pirated. So that's the thing right there. So, but I don't know. We might switch soon. But anyway, I just totally took us off the topic we were talking about. But you mentioned electric preheat. So preheat. Now, these units, are they always 100% outdoor units, or you have some element of return air? Or
no, it can be any.
Could be both. Okay.
Any custom air handling solution, whether it be 100% outside air, makeup air, energy recovery, or whether it's more of a heat vent style unit, like replacing a packaged rooftop.
Right.
And somebody wants to go fully decarbonized solutions with a packaged rooftop. In that case, if you're doing a heat vent unit, oftentimes if you don't have a significant amount of outdoor air, like if you're 20, 30% outside air coming into the unit, you won't need a preheat, because by the time you get the mixed air condition is high enough that you don't have to worry about a preheat.
Just make sure it's mixed real good. It's not stratified exactly. Onto the coil there.
Yeah. So there's lots of stuff to consider. But
yeah. So in those units for the primary heating, since it's a VRF heat pump condensing unit, you don't need. Well, maybe you need supplemental heat as an emergency, but you're doing your primary heating off of the heat pump function?
Correct. Yes.
Okay.
And it's really, if you want supplemental heat, it's really dependent on the owner's requirements, right? Some owners are like, no, I don't need it. If we have a failure, we'll just get it fixed.
Right.
And others, if they're in a critical application, then they'd want to have some sort of supplementary heat to in the event that there's a failure. But those are probably like hospital healthcare solutions.
Right. So it's easy to add electric backup heat in the beginning. It's really hard to add that after the fact. So I would be a big proponent of, because also you go in a defrost cycle, you have other things to consider. Heat pumps in the South where I'm at, they're like second nature to us. But I know in some areas, that's a good question for you. Heat pumps in general, is that new to Canada? Or they've been around, popular there, or not new? Okay.
No, my great aunt Marion had a air source heat pump in her house back in like the 70s.
Oh,
but
great aunt Marion was a trailblazer.
She
sounds like
God
bless her.
But she, sorry, no, not her. I mean, no more on her. But like heat pumps have been pretty since I've been in the industry 23 years, and we've always been talking about heat pumps. But performance of heat pumps has really changed from 20 years ago to today. Even in the last 10 years, we became the LG VRF rep about 10 to 11 years ago. And at that time, there was only a couple real manufacturers in the space. And we were all touting, I think it was like -4 degrees Fahrenheit performance. And so that didn't really raise the eyebrows of too many people here locally, because our design day is between -6 and -10 degrees. And if we go up to Ottawa and Sudbury, which are northern Ontario climates, you're talking -20 degrees Fahrenheit, -23 degree Fahrenheit design days. So -4 kind of hurt. The other side of it, not hurt, but made it difficult for widespread adaptation of the product. But over the last 10 years, and quite quickly, we went from a -4 degree Fahrenheit to a -15 degrees Fahrenheit to now it's a -30 degrees Fahrenheit operation. So -30 degrees Fahrenheit, when you look at southwestern Ontario, that gives you a lot of buffer between -3, -6 degrees Fahrenheit, and -30 degrees Fahrenheit. So we're really working in the meaty part of the curve of its operational envelope. So that, coupled with the LG, not just LG, but the VRF manufacturers making the commitment to bring in 575 volt 3-phase, has been another piece that has really helped us, because the Canadian market, everybody wants to use 575 volt 3-phase. We don't have
really.
We have 208 volt 3-phase. We have 120 volt single phase. In industrial complexes, you'll see 460 volt, just like you guys have. But majority of Canada is on 575 volt 3-phase for major loads. So having those manufacturers bring in 575 volt 3-phase and then have the -30 degree Fahrenheit operational envelope has made LG and VRF be a more ubiquitous product in the marketplace, which has been really effective when you tie it back to the efforts for municipalities and the province and the federal government targeting electrification and decarbonization, because VRF is a really great solution to address that in most markets, most market verticals.
Right.
Schools or apartments or multi-residential buildings, that sort of thing.
So let's talk about that for a minute, because we were chatting ahead of time a little bit about, like, the U.S. is so diverse in its, consideration of E&D, electrification and decarbonization. And I'll do presentations in Alabama, and I'll bring that up, and they're like, we don't do that here, and I'll go up to New York City, and God forbid you say anything there against it. It's like, you're worried, you were fearing for your life. But, I'm always curious as to the sentiment of the area. Like, some folks, like in California, it's a religion. Like, I had some engineers on my show, and I'm like, it's seen that way out here. It's seen this way over here. What is it? How is it in Canada? That's what I'm trying to ask. That's the question I'm trying to ask.
Yeah, I think it's more of a, we have a wide array of sentiment, if you will, but with a larger sentiment towards, yes, electrification, decarbonization, like larger sentiment being closer to what you're seeing in California and New York than what you're seeing in Alabama.
I mean, how much of a project is driven by that? Like,
I'd say that
a big part of the project.
I'd say that most projects now today are becoming electrified, whether or not, or not necessarily always electrified, but decarbonization is a big piece of the conversation. And whether that's a large industrial warehouse, we've gone through a period where we've done a ton of like 100,000, 500,000, 600,000 square foot warehouses that are fully decarbonized.
Where before, let's talk about that for a moment, because there might be folks on here listening who don't, there's a lot of new guys listening to the program. So when we say that, we're saying no gas heat, basically. In terms of our industry, decarb can be many different things in the world, but in our industry, we're usually referring to gas heat versus heat pumps or electric heat, right?
Right. Yeah.
Okay.
Yeah.
So you normally do gas heat in that big warehouse, but you're doing electric heat or heat pumps.
Yeah. There is a green decarbonization standard in Canada that we use. And it allows gas heat, but it has to be below -10 degrees Fahrenheit, I think it is. So down to -10 degrees Fahrenheit, your building has to operate fully on electrical loads. Decarbonization electrification in Ontario gets used kind of like interchangeably.
Right. It's kind of one. Yeah.
Well, because not our entire, but like 80% of our electrical grid is either nuclear, hydro, wind, and solar. So that makes up the vast majority of our hydro grid, with between 10 to 20% being natural gas. So if you go electric, you're offsetting 80% of your carbon load on your building.
Whereas a lot of places around these parts where I live, if you were to do that, you're burning coal or gas at the plant.
Exactly. Yeah.
It's not really doing a whole lot in terms of the end goal today. Maybe in the future it will, I don't know. But 80% nuclear, I like that.
Yeah, well, it's more like 60% nuclear and 20% like wind, solar, hydro.
That's good.
So there's lots of, we still call in Ontario, all of our electrical authorities the hydro company.
Oh, really? That's just how you call them?
It's kind of like, it's people like hydro, like it's a funny thing because hydro is literally like water over the waterfalls, like things like that. But we just call electricity hydro here. Like, it's weird.
Well, maybe you'll update to coal burning, like the modern plants, right? No.
Yeah, possibly.
Joke, yeah. So, big fan of nuclear energy. I think it's the best of all,
Yeah. We have a lot of nuclear.
Everything's got their trade-offs. Like, there's engineering trade-offs to any technology, right? There's nothing perfect, but
for sure. Yeah. No, but basically I was talking to my director of engineering sales earlier today, and I was asking him like what's the sentiment from the engineering groups on electrification, decarbonization. He said that it's basically the leading decision in every application, whether that be doesn't matter what market you're talking about, whether it be a school, whether it be a new office or anything. Electrification is being reviewed and talked about at a high rate. And then, like, my view of it is that there are lots of great technologies available today that can get us to like 90% electrification without being crazy. Like, if you look at even pre-configured air handling solutions with air source heat pump capacities to a very low temperature, not quite getting down to not quite where VRF is at the moment. But you look at VRF, so heating and cooling, we know already we can do that with technologies that are available today and are actually economical. And then the real challenge is outdoor air and how we address outdoor air, because that's where the biggest loads are in your facility. But there's different ways to do that, and I mean the common way was always energy recovery, and now there's regenerative core energy recovery solutions.
What do you see mostly there? Plate and frame?
No, we see wheels, like high efficiency wheels, like 6 and 8 inch deep wheels, and we see a lot of regenerative core. Not a lot, but we see regenerative core as well.
So you're doing enthalpy recovery, not just sensible. Got it.
Almost like I'd say the vast majority of our projects have both enthalpy and sensible and plate to energy transfer. So the other side of it that we've been at O'dell have been very vocal about over the years is reducing your ventilation air using the indoor air quality procedure with ASHRAE standard 62 as opposed to using the ventilation rate procedure. There's a lot of products out there. We have represented Envirid for a number of years, and Envirid is a great solution. It allows you to reduce the amount of ventilation air you bring into your building. So immediately, it's basically for every 1 CFM you reduce, it's 100% efficiency on that CFM. So
for those listening, and for me too, because I might be a little stale on this. So we're talking about the IAQ method. Is it still called the IAQ method?
Yep. Yeah.
So you can, per ASHRAE, you could either ventilate the space, which is bring in fresh air and remove some of the old air, or you can clean the air that's in there and provide less of the ventilation. So in doing that, you save energy because it costs a lot of money to bring in outside air in terms of heating it and cooling it, dehumidifying it, all those things. So you're seeing the IAQ method being implemented more?
I would like to see it being implemented more. Yeah. I think with the ventilation rate procedure within ASHRAE 62, it's very easy. mean, you take your square footage, you take your number of people. It's very prescriptive.
You got an airflow monitor. It makes sense in your head. You can see it. You can believe it. It's the other
this
stuff.
Plus this equals this, and that's what you have to do. So it's easy. It's a calculation that's being done kind of without any thought from the standpoint of the engineering consultants. I mean, there's obviously thought goes into it from a VAV versus a constant volume application and DOAS versus like dedicated outside air versus recirculated air systems. But IAQ is very different because you're having to look at the application of the project. You have to look at the use of the space. What is off-gassing a space? There's 8 contaminants of concern that ASHRAE has identified that you have to make sure you do a mass balance equation to make sure that you bring in enough ventilation air or you're doing enough cleaning in your space to effectively maintain indoor air quality at the levels you want to.
And you're measuring those contaminants, documenting that. So, and that could be a big savings, especially if you have like a big arena or a stadium or.
Yeah, with using the Envira technology, even outside of using a technology like an air cleaner, oftentimes, depending on your outside air quality, right, because that also comes into effect, you can reduce your ventilation rate by 15-20% just by using a different calculation method. You're not even, but then you add in an element like air scrubbing or cleaning in your space on the recirculated side, you can now reduce your ventilation air by up to 70%, in some cases 80%, eliminating 80% of your load into your building due to ventilation. So there's a real opportunity there to address that. The one challenge we always hear is about CO2, because your CO2 is actually, carbon dioxide is not a contaminant of concern based off ASHRAE standard 62.
It's funny that as long as I've been in the industry, people don't understand the CO2 is really a trace gas. It's not. And I think in submarines, they control it to like 4,000 parts per minute CO2 or something like that. And we look at 500. So yeah. No, I think the CO2 thing needs to be addressed a little better.
Yeah, there needs to be more education and knowledge on that particular item, because it is the one largest challenge to effectively mitigating outdoor air, how much outdoor air you're bringing into space.
It's so ingrained, and I was always taught it was a trace gas in terms of it's a good indicator of how many people are in the space, and people give off stuff other than CO2 that's not good for the space. Perspiration, ammonia, that kind of thing.
Yeah, 100%.
So it's like that's and while you're in the space, you want it to be clean. But anyway, that could be another show. We'll have to get you back. We'll find some more experts to come on and talk about that. So so let's see here. We talked about electrification, decarbonization. We talked about when you're going to get on the imperial system there and get off this metric thing. You've also got that weird voltage, so we'll have to figure that out. Okay, so how about A2Ls? Maybe let's talk a little bit about that. So you made a comment when I was talking to you before how you're having to change because of the U.S. And I always see the U.S. is changing because of the international community, probably not Canada, but maybe over in different parts of the world. But so here it's a total mess. Like I'm sure it's the same way there. To me, it was not planned very well. What do I want to say that I won't get me in trouble? I'm just going to say it's been in a mess. That's what I'm going to say for that, so I don't get some emails or comments or whatever. But what are you guys seeing up there?
Yeah, you guys made it a mess. We actually don't have it's obviously as part of the. Correct me if I'm wrong here, but the Paris Protocol and Kyoto, all those different protocols. We do have a phase out plan in place for our 410A and other gases. But right now it's very limited to a very small subset of products. I think some chillers and some residential equipment under 5 tons can't use our 410A and have to move to an A2L. Outside of that, though, like custom air handling, industrial, commercial buildings, VRF, we can all still use our 410A here in Canada.
Oh, really? So like a 20-ton package rooftop unit, so we're still on A2 on 410A for VRF till the end of this year. In terms of when it can ship from the factory, there's a whole other schedule on like remnant inventory, like when you can install it. But for right now, you can buy a 20-ton package unit with 410A from a factory. It can ship from a factory. Okay.
Yeah. So, but the reason that we are transitioning is supply. So all of the major kind of not custom, but unitary and semi-unitary, whether you're talking about Valent or Aon or Daikin or Carrier, Trane, Lennox, they're all mass produced in the United States, and they have effectively had to make changes to the A2Ls. And so now we're by proxy are making that conversion, but it's not being driven by our government yet. Last we heard, and if you were to go onto our governmental websites, you would wish that you could go look at building codes, because building codes are easier to read and understand than our Canadian government and how they explain the phase out. So, but from farthest I can tell is that they've pushed out even further phase out of R410A in Canada, even discussion about it to 2027. So we've got lots of time between now and 2027 to for you guys to get it figured out, so we can just do what you do.
I don't know if we can
clean up. Well, I'm interested. I've heard some really interesting things about R454B down there and the access to R454B, and are those the stories about a jug being $1,000 and are those stories accurate, or is it just
no, they're true. They're real. If you can find them, they're very expensive. I just got an article or read something that the relief has started to happen, or you can get some now, but it's still expensive. It's probably going to be by the end of the year, fourth quarter is when things will be back to normal, is what the prediction is. But so I don't know.
Let me ask you a question about 454B versus R32. Why do you think we're in this predicament where we have two different? I feel like we're back to Sony and Beta, VHS and Beta, or BACnet and LawnWorks, and now we've got 454B or 32. So, what's the sentiment in the States on those two different?
Well, right now, probably you can get 32 easier. So there's probably people are like, well, that's the better one to use. But overall, if you historically, when you go back and when the mandate came down, you had to change from 410A. The manufacturers basically had two choices, R32 or R454B. From a manufacturing perspective, you're going to pick the one that, there's all different reasons you're going to pick one versus the other. But one of the major ones is the engineering and redesign requirements of the equipment. So 32 has a little bit higher operating pressure and temperature. So if you're using 410A, 454B is more naturally fits into the engineering scope, so you don't have to do a lot of re-engineering of the machine. There's also the political aspect of it. I think Daikin makes R32, so do you want to be part of that, contribute to that? I don't know. Basically, what happened in the States, to the best of my knowledge, is pretty much everybody other than VRF is using 454B, excuse me. So that's not everybody, but most package rooftop unit split system folks are using 454B. And most VRF folks are using 32. I don't know why that is, other than I know 32 has been very prominent in VRF systems around the world. All this stuff's not new in the world. It's just new to the States and new to Canada, apparently. But it's been around for a while. So that's kind of when you have to make the decision from the engineering trade-offs. That's why most manufacturers went with 454B on the thing. And the major hiccup in the 454B, from what I read, and I've talked to a lot of industry leaders, is it hasn't been the refrigerant itself, it's been the tanks. So the tanks they're different than standard tanks. The A2L tanks have a different relief valve on them. It has a relief valve as opposed to a rupture disc. And there was some supply chain issue with that one component that caused this huge, terrible ripple effect. But how accurate that is, I don't know. I just know I see all the texts and complaining about it I do a lot of stuff online, and Instagram and TikTok and LinkedIn, and they're like, this is a mess, and it's, can you imagine being a tech right now? It's so hard. You've got all these different refrigerants you got to carry.
Yep.
You're trying to start up this unit. You go down to the store, you don't have it. You got to come back. I mean, it's real hard for the guys on the front lines. That's who I feel, the worst for. For us, as manufacturers, reps, it's an inconvenience, but it's not like we're not on the front lines dealing with these customers who can't get any AC, which is not fun. So,
yeah, and carrying 3 different and taking up space in your truck with 3 or 4 different cylinders of gas, and
yeah, it's a lot going on for sure. So,
cool.
Well, it sounds like you'll be getting more of that education as time goes on, and your government gets more involved in it. But you got time, so that's good. You guys are doing it right.
Yeah, I don't think they're not involved. I think that I think the issues that they're having in the States have probably helped us as far as
for sure
the integrate. They're like, okay,
learning experience.
Let's see what they're doing down there. Let's see what we can learn from them. That's just me speculating. But they certainly, and we know that ASHRAE and HRI have made some overtures to push out some of these requirements because of the issues they're seeing. So let's figure out, let's get comfortable in our new shoes now, and then before we start trying to do the next level.
That's good.
Which I think will be interesting. So
good stuff. All right, we covered a lot of great stuff. To finish up, I always like to ask you, because I get a lot of questions online. A lot of folks want to get into commercial HVAC, right? And there's kind of a standard process in the States, and I'm talking about like commercial HVAC sales, which is what your organizations, focus on. So if someone's in Canada and listen to this, and maybe they're in college or they're a service tech who wants to switch over, an engineering, professional who wants to, who's crazy and wants to go into sales. I'm half joking. I was in sales for 20 of my 29 years, and I loved it. There was a time when I loved it, and there was a time when like, okay, I don't love it anymore. I'm gonna do something else, and that's fine too. What do you suggest for folks who want to get into commercial HVAC sales in your area?
Well, I would say that at both the university and college levels, the education you get there is transferable, but not specifically applicable. So I took I'll talk about my experience quickly. Is that I took mechanical engineering at the University of Waterloo, graduated from there, and ended up in consulting. And when I went into consulting, I felt like I was learning a trade because none of the stuff that I was doing, from running ductwork to, Q equals 1.08 CFM times delta T, like all these things, right? None of that was really, it was taught, but we were taught at the first principles levels, not at the rule of thumb level. So understand that HVAC is a trade, whether you're coming into it from a sales, consulting, engineering, application, like it's a trade that needs to be learned. So I think lifelong learning, continuing to learn in the market, in the space, and understand and be inquisitive about products and how they apply, how they work, and how they can be applied, and what they do, what the advantages and disadvantages of them are. Look beyond the marketing of products. I know marketing is important, but the O&M manual is probably more important. Read O&M manuals, understand what the manufacturer intended. That stuff will all give you a great foundation for being a strong salesperson, because you can have the conversations not only with the owner, but with the engineer, and also with contractors on how the thing's actually supposed to work. But we have salespeople here at O'dell that came from every walks of life, whether that be professional engineers from engineering school, college from the CET programs, and also we have some techs that have been transitioned from being a tech to a salesperson. And each one of them has different strengths and works better with different customers just because of their background and their knowledge and how they interact. So the one thing that's consistent with them all is they all have a good personality and can carry on a conversation and understand the customer, how to help support a customer and make the customer be really the hero in the story. It's not about them, it's about the customer and solving their problems and supporting them and being communicative. So those are the things that are the most important. All the other stuff can be taught by either a company like myself or other reps around the world that are doing the same thing. But being quick to respond and providing value to your customer are the two major things that you need to make sure you're able to do. And that all comes from lifelong learning and continuing to be inquisitive and understand. Read your ASHRAE journals. Read your mechanical business. Join your local ASHRAE chapters and spend some time with other people in the market that are doing the same thing as you, and build a team of people internally and externally to you that you can call on to ask questions. I did that, and I continue to do that in my career.
Excellent.
So that's what I would say.
That was such a good closing. I'm going to shut up so I don't say anything stupid and ruin it. And Nathan, thank you for your time, and hopefully you'll come back to the show.
Sure thing. Thanks, Tony. I appreciate it. It's a lot of fun.
Thank you very much. And thank you so much for listening to HVAC TV. Please check out our YouTube channel if you want to see all of our videos, which is HVAC TV on YouTube. And thank you so much again for listening.
Thank you.